Hi, Assalamualaikum everyone. Before we begin with the basic assembly language chapter, please install Atmel Studio 7.0 into your computer and then follow this video so that you know how to set up and simulate an example of the assembly code program. If you haven't installed the Atmel Studio 7, you may find the link that I have posted in Kalam. So you can click on the link under the reference tab. So it will lead you to the microchip website, and then you can find the downloads. So you can download the installer here. So you can either download the web installers where you need to install it with an internet connection. So make sure that you have a good internet connection when you install it using this. And then you can also download the offline installer. So this is quite a big file, 874 megabyte. So if you don't have a good internet connection, so you might want to download the offline installer first and install the software. After the installation, you can see the icon of the Atmel Studio 7.0. Double click on that. Then the start page will appear. So the start page is basically some links to getting started with Atmel Studio and etc. So next what we're going to do is to create a project for our assembly language programming. So you click on File, New Project, and then here we will select on the Atmel Studio solution, blank solution. So we are using blank solution because let's say if we want to create multiple files for the assembly program, so we can create in one solution. So next, name your solution. So let's say I name it by week. Let's say it is week 1, so I name it as week 1. So under this solution, I will create all of the exercises program. And then for the location, okay, you can select any location that you like. Like for example, for this subject, I create one folder which is program. So I store all of the programs for this subject in this folder. So you can select the folder and then click OK. After that, under the Solution Explorer, you will see the solution that you have created, but nothing is in it right now. For this one, the wizard, you can dismiss it. Alright, now right click on the solution, add new project. Okay, since we are writing in assembly language code, click on assembler, AVR assembler project. So you can name your project. So let's say activity 1 and then OK. Now you need to select a device. So in this course, we are going to use Atmega64. You can search for that to find it. Okay, select on Atmega64, and on the right side here, make sure that your device has a simulator because you want to run a simulation with Atmel Studio 7.0. And then click OK. Now you will see some folders under the project of activity 1, and then there is the main.asm. So this is your program where you will write the assembly language coding inside here. So next, before we start with the programming, we need to set up the project. So under the project activity 1, you right click, click on properties, So under the build configuration, okay, we want to have the debug and release with the same configuration. So you select on all configuration, and then under device, make sure that the device that you select is correct. So let's say that you select the wrong device, you can change the device by clicking here. So this is good. And then under tool, okay, since we want to run a simulation, we select the simulator. Okay, and then after that, we have finished the setup. So you can hit Ctrl S to save the configurations, and then you can close it. Then we can start to program our application. Okay, you can delete this all and start anew. So first, what you need to have in the program is a comment header. So any line of comment should start with a semicolon. And then first, you can put the code of this subject, BTE3254, and the name of the subject, Microprocessor and Interfacing. And then next, another comment, you put a name, the author. So you put your name. So I'm going to put my name here. And then next, date. For example, June 1st, 2020. And then the title of your activity. So let's say I just put here activity 1. And a short description of your activity. So let's say simple program. Okay, so make sure that you have all of these comment header items in every program. Next, we want to divide the program into 3 segments. So let me just write the comment. Here I want to have the data segment. So I put data starts here. So in between these comments, I can put any data. So you will learn this in the next lecture. So data ends here. And then the second segment is the main program. So you put the comment, main program, start, main program, end. And lastly, you can have a segment for the subroutines. We will cover subroutine in chapter 4 later on. Subroutine start and subroutine end. Okay, next, at the beginning of the program, before you start the data, you need to include a file. So dot include m64def.inc. And then .org 0. Then relative jump towards start label. So the start label is actually the starting of the main program. So we put the label here, start. And then inside the main program, we want to add an instruction of load immediate. Let's say R17, and we want to load it with the value of 5 in decimal, and then load immediate R18, and then we can also represent the immediate value in hexadecimal, 0x hexadecimal 6a. And then we can also load an immediate value in binary format, 0b. So let's say 10011100. Then we add an infinite loop, forever as the label, and then jump to forever. Okay, at the end of the program, dot exit. Okay, let's see what will happen if you run this program. So first, in these two lines, we have dot include and dot org. So the dot include will include a file. So this is the file that will be included. So we already discussed this in the previous class. And then next, .org. So as you can see, these two lines are not the assembly language code, because they are actually called the directive assembler, where the instruction will direct the assembler to do something. So for example, this one, it wants to include a file, and this one, .org, is to is the origin, where the program will start pointing at the address 0. So basically, anything that starts with a dot in front is a directive assembler, which we will discuss in detail in chapter 3. So next, the program starts with the instruction of jump start. So this is actually to jump towards the main program, because we want to skip executing the data. So afterward, the program will execute the LDI load immediate R17.5. So this is basically will load a value of 5 into the register of R17. And then the next instruction is load immediate with a value of 6A. So we want to load the register 18 with the value of hexadecimal 6A. And then this one, load immediate register 19 with the value of binary 1001. So that is actually hexadecimal 91100 is C. So hexadecimal 9C into register 19. We have the infinite loop here. The reason we add it here is to avoid a runaway code, so that the program will not execute the subroutine, which we will add on later in chapter 4. Because for subroutine, it is only executed if we call it inside the main program. And also the infinite loop is to keep the microcontroller in standby mode, so it can respond with any interrupt that comes later on. So we are done with the program, so make sure that you save the program first. And now we want to simulate the program. The purpose of simulation is to see what happens line by line when the program runs. But before we can simulate, we need to build the project first. So you can click on build activity 1. And now the output of the build process will be shown here. So as you can see here, build 1 succeeded or up to date, 0 failed and 0 skip. So ensure that before you simulate the program, there is no error. So if there is any error, you need to understand what's the error of the program and troubleshoot the error. And then in this output also we can see some statistical data of the program, of which memory, is it the program memory or the data memory used with the program. Okay, so we are done with building the project, so you can close the output now. To debug, you can click on Start Debugging and Break or hit alternate 5. And now your program is ready to debug. So from here, let me highlight some buttons here. The first one is step into, and the second one is step over. So let's discuss a bit about these two. So we have step into and step over. Okay, let's say that in your program you have some lines of program inside the main program. So you have start, and then you have your program here, and then suddenly here we want to call a subroutine. Let's say the subroutine is called 1. And then we continue with the program, and then we call another subroutine named 2. So down here we have so next we have the infinite loop, and here we have the subroutine label 1 with the program. So subroutine is just like function in high level language. So we have 2 with the program. Okay, let's go over step into first. So for step into, so it will execute the first line, and then you when you hit step into, you go to the next line, another step into, line by line by line. And then next it will call the subroutine 1. So this program will then jump towards 1, and then we hit again the step into, so it will run 1 by line by line, step into, and step into, and then it will return to the subroutine and then step into line by line. Okay, that is step into. What about step over? For step over, it will also start at the first line. When we step over, it will go to the next line, execute the next line, step over, step over, step over, and then when it comes towards the subroutine, when we step over, it will execute the whole it will execute the whole subroutine, and then it will go back to execute line by line in the main program. So that's the difference between the step into and step over. Usually the step over is used when we are sure that the subroutine is correct. So that's why we run the step over. But if let's say we still want to check the subroutine, we can run the step into. So we check the subroutine line by line. Okay, notice that here on the right side we have the processor status. So the processor status will show what's the content of the registers inside the CPU. So we have the registers from R0 until R31, and then we also have the program counter, stack pointer, the index register XYZ, the status register, and the cycle counter, how many cycles does it already execute, and the frequency. So the frequency, how much frequency for this processor, and then the stopwatch, so how long has the program been executed. So let's try to click okay, if the display of the processor status is not shown on the window, you can click on debug windows. So you can click on the processors, okay, either the register to show all of the registers value, and then the processor status to show the processor status values, the registers, and then the IO, you can also show that if you want. So any of this window you can show it. And then if let's say you want to dock it on the window, you can drag and then you can place it by clicking on where you want to place it. So let's say at the bottom, on the left, at the top. When you release, it will be placed at the top. So let's dismiss this for a while. And these are the content of registers. This show all of the registers value from R0 until R31, and then here it will show the content of the memory. So the memory, it's either the program memory or the data memory. So let's try to debug this program line by line by using the step over. So when we click on the step over, so at first the program shows, if you notice the yellow arrow here, at first at the start of the debugging it will show at the rjump start, but when it shows at that line has not been executed yet. So when you step over, it will show towards which instruction to execute next. So this line will show to the next instruction to be executed. So now after we click on step over, the rjump start has already been executed, and you can see the content of the memory here. So let's say we want to show the flash memory, so we can click on the flash memory. So you can see that the content is changed, okay, from FF towards some code values. So these are actually your program code has already been stored inside the flash memory. So next, let's say we want to execute the LDI R175. We click on the step over again. So when you click on the step over, the LDI R175 has already been executed. So basically this instruction will load the value of 5 into R17. So as you can see, the R17 changed with the value of 05. By default, it was 0 before. So we can hit on step over again. Now R18 been loaded with 6A, and then next R19 will be loaded with 9C hexadecimal, and now it entered the the infinite loop. So when you click on step over, it will keep executing the infinite loop. So as you can see here, after I execute the infinite loop, there are 7 cycles. So basically the program executes for 7 microseconds after the infinite loop. So you can always see the registers value. Now the program counter is shown towards the address 4, which is the jump instruction, the infinite loop. Okay, that's all about the debugging. So now you can stop debugging. So it will show back your solution explorer. So now let's say that you want to start a new project, so you need to start your new program. So it's gonna be tedious if you need to type again all the standard templates. So what we can do in Atmel Studio 7.0 is you can save the template and then you can use it later on when you do different exercises. So basically you can leave the header template, the first 2 lines, because you're going to use it the same throughout the course or your test. And then on the date, you can delete the current date, and you can put here insert date. And then for title, you can put here insert title. And then description, you can also put here insert description. Okay, and then we're still going to use this, include the same org, the same rjump start. So your main program is here, so delete this part. So you can put here insert your code. Right, so we still have the infinite loop and then the subroutine and the exit. Okay, so we are done with the template. Now click on File, Export Template, Project Template from Activity 1, next. So you can name your template. Let's say BTE3254 template 1, and then you can describe a template. Let's say BTE3254 project template at mega 64. Okay, so the output location will be here and your template will be saved in a zip file. And then click finish. So now your template is ready. So if you want to use the template for a different project, you can click on File, Export Template. File, Import Project Template, and then you can browse towards the template. So you can from the previous file here, you can also copy and paste it to the different folder. So let's say I copy and paste it to this folder, so I can just click on Open. Okay, so it has imported the template. Or if let's say you want to add up a new project, from the solution you add a new project, so you can choose any template that you already developed before. So let's say template 1, and then click OK. So the new project will be appeared here with the template that you have saved before. So you don't need to write the comment header and the basic program again for your next project.